Hello friends, welcome to the Engineering Projects YouTube channel. We have started the series of Electronic Devices in Circuit Theory by Robert L. Balested. I am Mariam. This is the chapter number 2 of our series and its name is Semiconductor Diodes. Today we will discuss about clippers, and it is the very important topic according to exam point of view. What are clippers? Clippers are the networks that employ diodes to clip away a portion of an input signal without distorting the remaining part of the applied waveform. So basically, these employ diodes, and these will clip away the portion of input signal. This is the input signal, and this clipped away a portion of this input signal without distorting the remaining part of the applied waveform, and the remaining part is not clipped away, remaining part is not distorted here. Now we will discuss about the positive and negative clippers. The positive clippers are those clippers which will clip away the positive portion of the applied waveform, and the negative clippers are those clippers which will clip away the negative portion of the applied waveform. We will discuss about the series and the parallel clippers. Series clippers are those clippers in which diode is connected in series with the resistance, and the parallel clipper are those clippers in which diode is connected with parallel to the load resistance R. We will apply our input waveform at this point, and we will get the output waveform across the resistance. This is our input applied waveform. For the positive half cycle, this is the simple series clipper circuit, and for the positive half cycle, our diode, this is our N terminal and this is P terminal of diode. N is connected to positive, so for positive half cycle, our diode will be reverse biased and will act as the open circuit, and we will get nothing at this point at the positive half cycle. But for the negative half cycle, our N type is connected to the negative. For negative half cycle, our N type is connected to negative, so it will act as the forward biased, and we will have the closed circuit here, and we will get our output waveform in the negative portion. Negative clipper, our diode, this is P type of our diode, this is N type, and P type is connected to the positive terminal. For the positive half cycle, P type is connected to positive terminal, so our diode will act as forward biased, and we will have closed circuit here, and we will get our output across the resistance, and we will have the output waveform like this. But for negative half cycle, our diode negative is connected to P type, so our diode will act as the open circuit, and we will get nothing at the negative half cycle, and Vm is the maximum voltage. Biased series clipper. There are the two types of biased series clipper. Biased series clipper with negative biasing and biased series clipper with positive biasing. Negative biasing means that when our negative terminal of battery is connected to diode, then we will call it as negative biased. When positive terminal of battery is connected to the diode, then we will call it as the positive biasing. And this biasing is in the form of DC. This is our DC battery source. We will apply here the waveform. This is the DC battery source, this is our diode, and this is the load resistance R. Now here is Vi, and this is the DC, and DC is negative biased, so we will have the DC value in the negative axis. So in the negative axis, let us consider our DC potential is -3. We are considering it as -3. Now focus at this point. It is very important to understand. Our applied waveform is at +1. Let us consider here is +3. Okay, and here is -3. Our applied waveform tried to make this diode reverse biased, but our applied DC battery, our connected DC battery tried to make this diode forward biased because N is connected to negative. So this tried to make it reverse biased, this tried to make it forward biased. Here is a competition between the reverse biased and forward biased. Who will win? Now for input waveform, here is +1, here is +1, and the battery is at -3 potential. We have considered this, we have supposed this point -3. Battery is at -3, so we will get -2. So our battery with total potential of -2 will try to make this diode forward biased. So we will get -2 at our output waveform. We will get -2 at our output waveform. Now our potential is at +2, -3, we will get -1. So our output will be at -1 at this point. So our DC battery with total potential of -1 will try to make this diode forward biased. Now when our applied waveform is at +3, battery is at -3, we will get 0. So our output waveform will reach the point 0 here. You can see here our output waveform reach the point 0 here. We have finally look like this. Now at the point when our potential is at +4, our battery is at -3, we will get +1. Now let us see, this input waveform is winning here. In 3 cases our battery was winning, but now our input waveform is winning. Our input waveform tried to make this diode in reverse biased. Our input waveform tried to make this diode reverse biased. So for this point our circuit will act as the open circuit and we will get nothing. We will get 0. We will get nothing. For point +5, again our input waveform is winning and it will again act as open circuit. For point +6, again input waveform is winning and we will get open circuit. For again +5, +4, our input waveform will be winning and try to make this diode reverse biased and our diode will be open circuit here. But again for this point +2, when again +2 reaches, our battery with the potential of -1 will try to make this diode forward biased and we will get the potential here. Again we will get the potential here. Why we get the potential Vm plus V? For this I am trying to explain it. When our battery potential is our input waveform, here the input waveform potential is -1 and our battery potential is -3, we will get -1 minus 3 is equal to -4. And when the battery potential is -6, when battery potential when input waveform potential is -6 and battery potential is -3, then we will get the final waveform at -9. So that's why our peak is deeper than this input peak. Understand this point? Our peak is deeper than this input peak because both the input waveform and the battery, both trying to make it forward biased. So that's why our potential is higher there. So I think I have explained this output waveform fully. Now for this circuit, which is the negative clipper, negative biased series clipper, and for this circuit our input waveform here is positive. For the positive half cycle, our input waveform tried to make our diode forward biased, but our battery tried to make our diode reverse biased. Now we have to judge who will win. Our input waveform will win or the battery will win. Now for the input waveform, here is the +1 and battery is at the potential -3. This +1 tried to make this diode forward biased, but this -3 tried to make this diode reverse biased. We will get finally -2. So here the battery is winning and this battery will try to make it reverse biased, and when our diode will be reverse biased, we will get nothing because our circuit is open here. So we will get nothing at this point. We will get zero potential. For waveform of +2, we will get final result of -1, and again our battery is winning. With -1 indicate that our battery is winning. When battery is winning, it will try to make this diode reverse biased. We will have open circuit here and we will get nothing at the output waveform. When our applied potential is at +3, then we will have 0. Now at this point we get the 0 result because this DC tried to make it again reverse biased. When our applied waveform is at +4 and it is at -3, we will get +1. So we can say here that our applied waveform is winning here, and our applied waveform with a potential of +1 will try to make the diode forward biased. Our applied waveform with a potential of +1, when our input waveform is at +4, but because of this battery, our applied waveform with a potential of +1 will try to make this diode forward biased, and we will get +1 here. Understand? And when we have +6 here, let us consider when we have +6 here, and we will have final result of +3. So that's why we have a shorter peak than input peak. We have shorter peak than this input peak because our +6, which is the input peak, and we have the final peak as +3, which is shorter than, which is half than this input peak. So we get Vm minus V. So I hope you understand this term. When our point reached here, at this point -1, what will happen? When we have -1 from input waveform and -3 from battery, then we will get -4. It means that here will be negative and here will be positive. So both cases, here will be negative and here will be positive. So both the input waveform and DC battery tried to make it reverse biased. This is input waveform, which is the negative half cycle of input waveform, and here is the battery. Both are connected with negative. This negative tried to make diode reverse bias. This negative tried to make diode reverse bias. It means both are tried to make this diode reverse biased for negative half cycle. So for negative half cycle, our diode will act as open circuit and we will get nothing at the negative half cycle. I hope student I have clearly tried to understand. You will clearly got the concept of these two output waveforms, and this is very important to understand these two output waveforms. Biased series clippers with positive biasing. Now we have connected our diode with the positive terminal of battery. We have connected our diode with positive terminal of battery. Now in this case, this input waveform try to make this diode reverse bias. This battery is also try to make this diode reverse bias. So that's why we get nothing at the positive half cycle. But for the negative half cycle, this input waveform try to make this diode forward biased, but this battery try to make this diode reverse biased. We have the DC potential at the positive axis because it is positive biased. Now in this case we have a potential, it is trying to make it forward biased and it is trying to make it reverse biased. For this there is -1 for the negative half cycle, here is -1 for the input waveform, and for the battery we will have +3. Let us consider battery potential is +3. So we will get finally +2. So here the battery is winning. Here the battery is winning. Battery potential is plus. So the battery is winning and the battery try to make it reverse bias. So we will get, this is for the positive half cycle and the negative half cycle starts here. And this battery try to make it reverse bias. So that's why it will act as open circuit and we will get nothing. And for the -3 potential, -3, let us consider -3 is there, and for the -3 potential our battery is at +3 and we will get 0. So that's why we get here 0. And for the -5 potential, I am choosing the number randomly. For -5 input waveform, which will be here will be -5 input waveform. Our battery is at +3, we will have -2. So it means that our input waveform is winning here. Our input waveform is winning here. Our input waveform is trying to make this diode forward biased, but battery trying to make this diode reverse biased, and our input waveform is winning here. So our input waveform with a total potential of -2, here will be -2 with a total potential of -2 will be winning, and diode will be act as closed circuit and we will get -2 potential at the output waveform. For -6 we will get -3 and we will get the -3 potential at the output waveform. So I hope this circuit is similar to this one, and the logic behind these two output waveform is same. I hope you understand this, and the logic behind these two output waveform is again same. For this, diode is connected to the positive terminal of battery, and this for positive half cycle, our input waveform try to make this diode forward biased, and our battery is again try to make this diode forward biased. Both are trying to make this diode forward biased, and our input waveform is +1. Our battery is at +3. +1 +3 will be, our input waveform is at +1, battery is at +3, and so we will get +4. So we will get total +4 potential here. This is the +4 potential. Understand? Now with the potential of input waveform at the potential of +2, battery at the potential of +3, and we will get a total potential of +5. So that's why we get the larger peak, we get the inverted peak here. Sorry, not inverted. For +6 and the battery potential is +3, we will get total +9. So at this point we will get +9 potential. And again same for next terms, and I hope you understand this point. You have understand these 4 output waveforms, and these 4 output waveforms is very important to understand. I hope you understand all. Now we will discuss about parallel circuits. Now we will discuss about parallel clippers. These are the circuit for the simple parallel clippers, and these are the circuit for biased parallel clippers. For simple parallel clippers, our applied voltage is our applied waveform is applied here, and we will get the output voltage across the diode. In this case, we are getting our output waveform, our output voltage across the diode, not across the resistance. When we get our output waveform across the resistance, then we will call it as series circuit. But when we will get our output waveform parallel to the resistance, parallel to the diode, then we will get then we will call it as the parallel clipper. Now in this case, when positive waveform come, positive half cycle come, there will be positive, there will be negative. Our diode will be forward biased, and it will act as the closed circuit. It will act as the closed circuit. So our current direction will be like this, and we want to get our output waveform at this point. At this point, not at this point. Okay, so we will get nothing at this point. Understand? Because our current will flow in this direction, we will get nothing, we will get no waveform. So it will clip away our positive portion. And for the negative half cycle, when there is negative and there is positive, for negative half cycle try to make our diode reverse biased, and our diode will act as the open circuit. So the current cannot pass through here. We will get all of the waveform at this point, and we will get our negative waveform. Understand? Now for this circuit, for positive half cycle, our diode is reverse biased. It will act as open circuit, and we will get full waveform at the for the positive half cycle. But for the negative half cycle, our diode will act as closed circuit, and we will get nothing. We will get nothing at this point, and our negative portion is clipped away. Now we will discuss biased parallel clipper with positive biasing. Positive biasing means that our diode is connected with the positive terminal of battery. Our diode is connected with the positive terminal of battery. In this case, what will happen? For positive half cycle, this positive half cycle try to make this diode forward biased, but this battery try to make this diode reverse biased. In the previous case, for the series clippers, we add the terms +3 +2 like this, but in the previous case, our battery is connected in series with the positive waveform, so that's why we add these terms. But in this case, we will not do so, because we will just judge here who is winning. Our applied waveform is winning or our battery is winning, because the battery is not at this position, it is at this position. So in this case, applied waveform is try to make diode forward biased, but our battery try to make this diode reverse biased. So with positive 1 potential, our battery is at plus 3 potential. So our battery is winning and it will make this diode reverse biased. It will make this diode reverse biased and we will get positive 1 at the output cycle. We will get the same which is here. We will get the same point at the output cycle. Now for the plus 2, which is like this. Again our battery is winning, which is trying to make this diode reverse biased. It will be open circuit here and we will get the plus 2 waveform at the output. But for the plus 3, our battery is at again at plus 3 and in this case we will get this potential. For plus 4, again we will get plus 3 potential. For plus 5, again we will get plus 3 potential. Why we are getting the same potential? Because in this case our diode is like this. For plus 5, our input waveform trying to make this diode forward biased, but our output waveform, our battery trying to make this diode reverse biased. In this case, when there is plus 5 voltage for input waveform and plus 3 voltage for battery, our input waveform is winning, so it will make this diode forward biased and current will flow here for plus 5. So that's why we will get the same potential plus 3. Understand? And for the plus 6, again current will flow in this direction and we will get the same potential plus 3. But for this point, negative half cycle, where is minus 1, when minus 1 came, this minus 1 will try to make this diode reverse bias and this battery is also trying to make this diode reverse biased. Both are trying to make this diode reverse biased. So our diode will be open circuit here and we will get the same waveform in the output cycle and we are getting the same waveform as the input at the output cycle. So I hope you will got this concept. In this case, our diode for the positive half cycle try to make this diode reverse biased and the battery is trying to make this diode forward biased. Now we have to judge who is winning. Our diode is at potential plus 1 and the battery is at potential plus 3. So in this case, it is trying to make it reverse bias and it is trying to make it forward biased. So our battery is winning and our potential is plus 1 and battery potential is plus 3. Battery is winning. So we will get the potential of battery at plus 1. We will get the potential of battery. At plus 2, we will again get the potential of battery. At plus 3, we will again get the potential of battery. At plus 4, when there is plus 4 and here is plus 3, this plus 4 is trying to make this diode reverse biased and this plus 3 trying to make this diode forward biased, and now plus 4 is winning, and when the input waveform is winning, this will make this diode reverse biased and here will be open circuit. When there will be open circuit, we will get the same plus 4 potential at the output. So we get plus 4 potential at this point. For plus 5 potential, again we will get plus 5 potential. For plus 6 potential, again we will get plus 6 potential at the output waveform. Now for the negative half cycle, when there is minus 1, it is trying to make this diode now. This -1 is trying to make this diode forward biased, but this battery is also make this diode forward biased. Both are trying to make this diode forward biased for the negative half cycle. So for this point, for -1, it is trying to make this diode forward biased. Our battery is also trying to make this diode forward biased. So that's why we get the potential of battery for the negative half cycle, because both are trying to make this diode forward biased. In this case, biased parallel clipper, which are the with negative biasing, our diode is connected with the negative terminal of battery. In this case, when the positive half cycle came, this positive half cycle will try to make this diode forward biased, and our battery is also try to make this diode forward biased. Both are trying to make this diode forward biased. This is the similar case. These two cases are similar. So both are trying to make forward biased. So that's why we get the potential of battery, and the potential of battery is -3. We consider it. Let us suppose the potential of battery is -3. So we get the potential of battery -3 for the negative half cycle. For the negative half cycle, when there is -1, it is trying to make this diode reverse biased, but it is trying to make this diode forward biased. Now we have to guess who is winning, -1 and -3. We will get the potential of battery when here is -4, and it is trying to make this diode reverse biased. Battery is trying to make this diode forward biased. Battery is trying to make this diode forward biased, but -4 try to make this diode reverse biased. In this case, output wave, our applied waveform is winning, and we will get the same -4 at the output waveform. So we will get this -4. After, when there came -5, we will get -5 here. When there came -6, we will get -6 here at the output waveform. So these two cases are similar cases. Now for this case, for the positive half cycle, our positive is trying to make this diode reverse biased, because our P is connected to positive, and our battery is again to make this diode reverse biased. Both are trying to make this diode reverse biased. So our diode will be open here. We will get the same output waveform. When there is +1, output will be +1. When there is +2, output will be +2. When there is +3, output will be +3. When there is +5, +6, output will be +5, +6. So it means when there is open circuit, we will get the same output as the input. So that's why we get the same output. Now for the negative half cycle, when there is negative and there is positive, for the negative half cycle, it is trying to make it forward biased, and it is trying to make it reverse biased. Now we have to judge who is winning. It is forward biased. It is trying to make it forward biased with -1 potential, and it is trying to make it reverse biased with -3 potential. And you know, -1 is bigger than -3, so this will be winning. This is winning. Our output waveform will be winning, and we will get the same potential -1. It is the -1 here, and we will get the same potential at this point for when here is -4 and here is -3, and then battery is winning. We will get the battery potential here, and after this we will get this potential. So I hope you understand this. Now I am drawing a combined circuit. Now this is the combined circuit. This is our resistance, diode D1, diode D2, battery, and our input waveform will be here, and we will get output waveform at this point across these two diodes. Now in this case you can see D1, it is plus, which is trying to make this diode forward biased, and battery is trying to make this diode reverse biased. This is the case similar to this. This is trying to make this diode forward biased, and battery is trying to make this diode reverse biased. So we will get this output waveform. So we will have the output waveform like this, and this is the circuit. This is the diode, which is input waveform trying to make this diode reverse biased, and battery is trying to make this diode reverse biased. This is the case similar to this circuit. So we will get the output waveform like this. So I hope you will got all the topics, you will got all the points of this lecture. This is very important lecture. If you like our lecture, then kindly subscribe our channel. Thank you.